Here are solutions to perfect problem 5 for Math 112. In short, we're asked to simplify three things. We're asked to simplify 1 over, well, the notation is f prime of x, which is 1 over cosine of arcsine of x. This isn't, well, I mean, I guess at this point it's just to practice our trig skills, but this will actually be something really useful in calculus. It turns out this is the derivative of the function arcsine of x. When you're trying to find it in calculus, it's pretty easy to get this far, although we can't do it now because we don't know how to get this far. We don't know how to take derivatives. But when you do get here, you're not done. You have to simplify this thing, and that's kind of the hard part for most people in calc. We can do that, though. We can figure out, let's first deal with just cosine of arcsine of x. Let's simplify that, and the way you can do that is give these things a name. Arcsine of x is what makes this really hard. Let's call arcsine of x t. Just give it a name. Why do you give it a name? Because then we can say that this thing is really just cosine of t. Makes it look like an easier problem. You're probably confused at this point, like, what are you're just rewriting things, you're just changing names. That's true, but let me show you how we can make this work. If t is equal to the arcsine of x, then if I take the sine of both sides, I get that sine of t is equal to x. Maybe instead of x, we could think about it as x over 1. We'll write it as a fraction. Why would I want to write it as a fraction? Let me show you. Because if sine of t is equal to x over 1, what I can do is I can draw a little triangle and put t down here, and I know that sine of t is equal to the ratio of the opposite side over the hypotenuse. This is SOHCAHTOA, opposite over hypotenuse. So I know that opposite over hypotenuse has to be x over 1, or some similar triangle. So I get that this side is x, this side is 1. I can figure out this third side. Maybe I'll call that a for now. And I know that I can figure out what a is because I know that a squared plus x squared has got to be equal to 1 squared. So a squared has got to be equal to 1 minus x squared. So a has got to be equal to, maybe I should put in plus or minus the square root of 1 minus x squared, but since I'm talking about lengths, I don't need to. I can just call it the positive square root of 1 minus x squared. Okay, easy to get lost in the problem. Remember, what we're trying to do over here is we're trying to simplify cosine of arcsine of x, which we decided was the same as cosine of t. And I can figure out cosine of t because I have t right here, and I know that the cosine of t is adjacent over hypotenuse. Right, SOHCAHTOA. So the cosine of t is the square root of 1 minus x squared divided by 1. You don't need to write divided by 1, although maybe I'll write it just so that people don't, no, I'm not going to write it. It's that. So now that we know what cosine of t is, we know what cosine of arcsine of x is, and so we can simplify this derivative. We can say that this derivative is equal to 1 divided by the square root of 1 minus x squared. And I should probably write up here somewhere, don't rationalize the denominator. Why not? Because this is the form that most people leave the derivative in. If you look up in a textbook, you say, what's the derivative of arcsine? It'll give you this form right here. If that made sense, you're good. We're just going to repeat that 2 more times. So g prime of x, the steps will be very similar. I'll go a little bit quicker. G prime of x is negative 1 divided by sine of arc cosine of x. So really what I need to figure out is what is sine of arc cosine of x. That's hard to figure out, but what I could do is let t, although I've already used t, so maybe t1. Let's call this thing t1. Let's call that arc cosine of x. Why should we call it that? Because then all we got to do is figure out what is sine of t, which will be a lot easier. And we can figure out sine of t if we recognize that if we take the cosine of both sides here, if we recognize that the cosine of t1, all right, this is t1 here, is equal to x, or if you want it as a fraction, it's x over 1. So when I go to draw my picture, I can put my angle down here, t1, and I know that cosine is adjacent over hypotenuse. So here's my adjacent side, here's my hypotenuse. And so what I want to know is my opposite side. I want to know this guy, maybe I'll call it B. But I can figure out B in the same way I figured out A over here. Actually, it's going to end up being the exact same answer if you figure it out. It's the square root of 1 minus x squared. So when I'm trying to figure out what the sine, try that again, what the sine of arc cosine of x is, maybe I need a line down the middle there, I figure out that that's just the sine of t1, and I can figure out the sine of t1 by looking at this picture. Sine is opposite over hypotenuse, so the sine of t1 is just the square root of 1 minus x squared. Very similar to what we did over here. Alright, so now that we know what sine of arc cosine of x is, I can replace that over here and say that g prime is negative 1 divided by this thing, negative 1 over the square root of 1 minus x squared. I'm almost done. Third one will actually end up looking a little bit different, although really it's the same logic. H prime of x is equal to 1 over secant of arctangent of x, 1 divided by secant of arctangent of x squared. Sometimes you'll see that written as secant squared of arctangent of x. I'll put the extra parentheses to try to avoid confusion. Okay, so really what I need to do if I'm going to do this problem is figure out what is secant of arctangent of x, which is difficult. However, if I just give this thing a name, if I let t2 be equal to arctangent of x, I can make my life a little bit easier. Instead of trying to figure out, maybe there shouldn't be an equals there, instead of trying to figure out secant of arctangent of x, I just need to figure out secant of t2. And I can figure out secant of t2 if I recognize that tangent of t2 is equal to x. Maybe I'll call it x over 1 so that it's a fraction again, because as we've seen, when we draw these triangles, it's useful to have our trig functions equal to fractions, because using SOHCAHTOA, we get that tangent of an angle is opposite over adjacent. So if I'm calling opposite x here, I can call adjacent 1. And then to figure out my hypotenuse here, all I have to do is say, well, my hypotenuse squared is equal to this squared plus this squared. So my hypotenuse is equal to the square root of that squared plus that squared. In other words, I have this triangle right here with this angle T2. And so if you recognize that secant is, well, a few ways to do this. Okay, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So secant is equal to the square root of 1 plus x squared over adjacent, which is just 1. So what I get is that secant of arctangent of x is the square root of 1 plus x squared. So h prime of x is 1 divided by this thing squared, square root of 1 plus x squared, squared. And the square root and the squared cancel out, and we get 1 divided by 1 plus x squared. You can put the absolute, well, I'm not even going to put absolute value around this because x squared is always positive, because when we took the square root here, it had to be positive to begin with. So we don't need to add anything. We get h prime of x is equal to this guy. And that is the end of this perfect problem.